Hey guys, this is Mrs. Keith, and I'm going to do these quick notes over the properties of kites and trapezoids. A kite is a quadrilateral with exactly two pairs of congruent consecutive sides. And what I mean by that, I'm going to draw another picture up here just to kind of make it clear what I'm saying when I say that. So a kite is definitely not a parallelogram. Opposite sides are not parallel. Opposite sides are not congruent, but consecutive sides are congruent. So what I mean by that is this side is congruent to this side and this side's congruent to this side. Those are sides that are right there next to each other. If a quadrilateral is a kite, such as the one drawn in these pictures, FGHJ, then it has the following properties. And one of those is that the diagonals are perpendicular, just like with a rhombus, their diagonals are perpendicular also, but you have to be a parallelogram to be a rhombus. So that's why when we're proving that something's a rhombus, we have to also show that it's a parallelogram first, because it could just be a kite. So on this kite up here, the diagonals will be perpendicular. They form four right angles right there. Also, exactly one pair of opposite sides is congruent, opposite angles, sorry, is congruent. So this set of angles here will be congruent to this set of angles here. So one thing I want you to think about is how, when I drew this while ago, and let's think about this line drawn right here. I knew this was congruent to this, and this was congruent to this. I've created right here an isosceles triangle. And so in doing that, that would mean that this angle right here is going to be congruent to this angle right here, because those are base angles of an isosceles triangle. Also, I created an isosceles triangle right here. So that means that this angle right here will be congruent to this angle right here. And then we just talked about how this angle is congruent to this angle. So those are some other properties of a kite. So looking at this picture down here in kite WXYZ, angle WXY, this whole angle right here is 104 degrees. Angle VYZ, this angle right here is 49. And they want us to find the measure of the following angles. So because it's a kite, and I know it is because they told me so right here, I know that these are four right angles right here. So I know that this is 90, this is 90. I can figure out, if I do, I know that if I do 180 minus 90 minus 49, I'll get that this angle right here is, hang on, I have to do math in my head, 41 degrees. So 41 degrees right here. So that's angle YZV or VZY. You can say it either way. That angle there would be 41 degrees. VXW, which is, let's see here, VXW would be this angle right here. I know that we just talked about how if this angle over here, the VZY angle is 41, then this angle right here will be 41 as well. Well, those two angles have to add up to be, these two angles here have to add up to be 104. So I'm going to do 104 minus 41 to get that this is 53 degrees. And then angle XWZ. XWZ would be this angle right here. I know that in a quadrilateral, well, first of all, and I just figured out that this angle right here was 53 degrees. This triangle right here, I probably should do it with a highlighter. This triangle right here has their angles add up to be 180 also. We've got that 53-degree angle and the 90-degree angle. So 180 minus 90 minus 53 would be 37. So this angle right here is 37. This angle right here is going to be equal to that 37 as well. These are similar or they're not similar, they're congruent triangles. And we could use side angle side. That's another property I probably need to make sure I tell you. On a kite, when you draw these diagonals right here, not only are they perpendicular, but one of the diagonals gets bisected. The shorter one right here gets bisected. The longer one is the one that is like the line of symmetry. but this other one is the one that gets bisected. So I know this little segment here is congruent to this segment here. I should probably make that with 3 marks. And so I've got similar or congruent triangles right here. So these corresponding angles will be congruent. So this will also be 37 degrees right there. All right. In kite ABCD, angle DAX, which is this angle right here, is 32. Angle XDC, which is this angle right here, is 64. And it wants me to find the other measurement. So again, that's a right angle right there in the middle. So XDA would be this angle right here. I can do 90 minus 32. And I get that this angle is 58. So 58 degrees there. I was told that if this one's 64, this one there is 64, and this will be 58 as well. Angle ABC then will be that 58 plus 64. And that's 122. And then BCD is this big angle over here. So the angles in any quadrilateral, they add up to be 360 degrees. And so we talked about how these are congruent triangles within the kite. So this angle here will be 32 as well. So that makes this big angle over here 64 degrees. And we just said that this angle here was 122. This angle here is 122. And so when I do 122 plus 122 plus 64, I get 308. And the angles in any quadrilateral add up to be 360. So I can subtract that from 360. And I get that angle will be 52 degrees. Which, what will happen, another way I could have done that is to just figure this angle out here by doing 90 minus 64. And I would have gotten 26. And then this angle here would have been 26 as well. So they would have added up to be 52. So other options on ways to solve it. Okay. In kite PQRS, angle PQR, which is this angle right here, the whole big angle, is 78 degrees. Remember, when you name angles, the middle letters are vertex. The other 2 letters just tell you which direction you're going on the rays that create the angle. Angle TRS, which is this angle right here, is 59. Again, these are right angles right here. Find the measure of angle QRT, which is this angle right here. Let's see. I know, again, that this is an isosceles triangle. And I know that top angle of that isosceles triangle is 78 degrees. These base angles are equal. So if I do 180 minus 78, I get 102. And I know that those 2 angles are going to be congruent to each other. So I can divide that by 2. So I get 51 for each of these angles here. So angle QRT is 51 degrees. Angle QPS, which would be this whole big angle right here. They told me that one over there was 59. This will be 59 as well. And so 51 plus 59 gives me 110. 110 degrees. And then PSR, again, those angles in that quadrilateral have to add up to be 360 because it's a quadrilateral. So we've got 2 angles that are 110. We've got that one angle that's 78. And so those add up to be 298. When I subtract that from 360, I get 62 degrees, which means that each of these should have been 31 if I were to have calculated it using the angles inside those smaller triangles. Okay, a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. We don't have not both sets of opposite sides are parallel, just one set are parallel. So in this picture right here, we've got this side is parallel to this side. The other 2 sides that are not parallel are called the legs of the trapezoid. If those legs are congruent to each other, then it's called an isosceles trapezoid, similar to an isosceles triangle, but it's a trapezoid instead. So you're going to see trapezoids drawn different ways. You'll see them looking like this. This is a trapezoid because it has four sides and one set of those sides, opposite sides are parallel to each other. You could see it even drawn vertically. And in calculus, a lot of times we do it like this when we're doing trapezoidal rule. That would be a trapezoid there. You could see it where it's just kind of slightly off kilter. That's not a right angle formed there. So that would be a trapezoid as well. It could be drawn upside down, kind of like those right there. The two parallel sides, though, are called bases, and then the non-parallel sides are called the legs. If it is an isosceles trapezoid, then the base angles are equal. And you've got two sets of base angles, these two that are on this base and these two that are on this base. So those will be equal if it's an isosceles trapezoid. No matter what, even if it's isosceles or not, those angles will add up to be 180 because these lines are parallel. Same side interior angles will be supplementary. So what we learned about parallel lines and same side interior angles applies there. In an isosceles trapezoid, each pair of base angles is congruent. If a trapezoid has one pair of congruent base angles, then it is isosceles. I don't know why we have this written so many times, but we do. A trapezoid is isosceles if and only if its base angles are congruent. All right. And another kite one in the middle of our trapezoid stuff. Sorry, y'all. Angle ABCD, or in kite ABCD, angle BCD, which is this whole angle right here, is 98. So that's 98. Remember, the angles that are congruent to each other are the angles that are between the two legs that are not congruent. And so that angle 98 will be the same as let me get those going. This angle here will be 98 as well because those are opposite angles are congruent to each other. Just one pair of opposite angles in a kite are congruent. Angle ADE is 47. Again, we know that these all form right angles right here. And it wants me to find the measure of angle DAE. So if I do 180 minus 47 minus 90, I'm going to get that this is 43 right here. So that angle is 43, which means this angle here will be 43. BCE, which is this angle right here. If that angle is 98, if I do 98 minus 43, I get that that's 55 right there. So BCE is 55 degrees. And then ABC, which would be this whole big angle right here. I know that this angle right here is also 55. I can do the 90 minus 55 to get that this angle is 35 and this is 35. So this will be 70 degrees for angle ABC. Or again, the angles in a quadrilateral add up to be 360. All right, find, now we're actually going to work on trapezoids. So find angle J in trapezoid JKLM. Because this is an isosceles trapezoid, and I know that it is because those legs are congruent, these base angles are congruent here. I know that same side interior angles between these two parallel lines right here are going to be supplementary. So if I do 180 minus 124, I get that this angle is 56 degrees. So the measure of angle J equals 56 degrees. In trapezoid EFGH, segment FH is 9. That's this whole segment right here. I know this is an isosceles trapezoid again because I have these two legs that are congruent and I have the bases that are parallel to each other. I mean, it's just drawn sideways kind of. So if that's another thing I didn't talk about a while ago, and we should have had it up there. If it's an isosceles trapezoid, your diagonals are going to be congruent to each other, just like on a rectangle. But a rectangle is a parallelogram, so you've got to make it clear again that a rectangle is a parallelogram because it could be an isosceles trapezoid if all you know is the diagonals are congruent. But if this is an isosceles trapezoid, segment AC will be congruent to segment BD. All right, so we're told FH is 9. That means well, I know segment FH is congruent to segment GE. And I know that FH, because it's 9, that's what segment GE is going to equal as well. I know GE equals AE. plus AG. Those two set parts add up to be that. So if I'm trying to find AG, then, and I know AE is 6.2, then I can just subtract 9 minus that 6.2, and I get 2.8. So AG will equal 2.8. All right. Find each value so that the trapezoid is isosceles. Well, if this is an isosceles trapezoid, that would mean these base angles have to be congruent to each other right here. So that means 5x squared plus 32 has to equal 7x squared. So moving the 5x squared over here, I get 2x squared. Divide by 2, I get 16. So x will equal plus or minus 4. I should probably show that work. To unsquare that, we take the square root of both sides. But when you take the square root to solve, you always have to remember there's a plus or minus possibility. And so that means x equals plus or minus 4. And normally, you know, we tend to a lot of times ignore the negative because it makes an angle negative or it makes a side negative in geometry. But if you plug that -4 into those angles, you're going to be squaring it and it'll make it positive. So both answers are applicable here. On the next problem, I know it's a trapezoid because these bases are parallel to each other. They told me segment AC is 2z plus 9 and segment BD is 4z minus 3. Well, no, AC has to equal BD because in an isosceles trapezoid, diagonals are congruent. So this is 2z plus 9 will equal 4z minus 3. So z will equal 6. All right, mid-segment formula. Kind of like if you'll remember, we did mid-segments in triangles. A mid-segment always connected the midpoints of two sides of the triangle. So I know that's a midpoint because those parts are congruent. These parts are congruent, so that's a midpoint. Well, the segment that connects those is called the mid-segment. Mid-segments are parallel to the sides that it doesn't touch there. And so all the properties of like parallel lines are applicable there. So the mid-segment of a trapezoid is a segment whose endpoints are the midpoints of the legs. So this point here is a midpoint, and this point here is a midpoint. And I know that because of these markings here and these markings here. So that makes this segment a mid-segment. It will be parallel to the bases as well. The length of the mid-segment is 1/2 the sum of the length of the bases. And I usually write it like this: mid-segment equals half of base 1 plus base 2. I mean, just kind of thinking through that. So here, if I'm finding KL, I know the mid-segment, which I mean, I guess I should call it KL. KL is going to be half of the two bases, 16 and 26 added together. And so that gives me 42. So that makes that 21. So this is 21. And so another thing I want to show you is that the length from, or if you think about the one side being 16 and the mid-segment being 21, that's a difference of 5. It should be a difference of 5 going from 21 to the other base as well. So you should see that it's almost like a ladder. You go from your smaller one to your middle one to your bigger one. Okay, so like here, you can see that's a difference of 2 right there. So this will be a difference of 2, which means this is going to be 9.5. But if you actually calculated it, you would say ST, which is the mid-segment, is going to be half of the two bases added together. So PQ and NR. So ST, which is 7.5, will equal half of PQ. I'm going to call that X, plus NR, which is 5.5. I'm going to get rid of the half first by multiplying both sides by 2. When I multiply the right-hand side by 2, I get 15. When I multiply the left side by 2, I get 15. When I multiply the right side by 2, that cancels that, and I'm left with X plus 5.5. And then when I subtract 5.5 from 15, I'm going to get 9.5, which is what we figured out it would be up here. Okay, on this one, again, your mid-segment EF will equal half of your two bases added together. So that's going to be 18.3. And so goodness. I'm not doing very good in my head right now. 18.3 times 0.5. So 9, sorry, I put that decimal in the wrong spot. So 9.15 will be that length right there. That was a mean one. So on the next one, and one good thing is on this next test, you actually get a calculator. So you won't have to worry so much about that. On the next one, we know YZ equals half of those two bases, VU and WX added together. So YZ is 22.9. And then we've got a half, and VU is 35 plus, I'm just going to call it X there. Multiply both sides by 2. So we get 45.8. And then we've got 35 plus X. So subtract 35 from that. And I get 10.8. Okay. All right, on the next one, we have a kite and a trapezoid here. So I know that these two angles right here are congruent. They're showing me that they are right there. I know that because that shape is a kite, that this angle here, oh goodness, sorry. This angle here will also be 137. And because those angles that are between the non-congruent sides are always congruent to each other. So I can figure out X by doing 137 plus 137 plus 22. Which adds up to be 296. And then if you subtract that from 360, I get 64 degrees for angle X. Angle Y, so I know those two angles are equal, so this is 137 here also. And so these two, because they're between these parallel sides right here, these two angles have to add up to be 180. So if I do 180 minus 137, I get that that angle marked with a Y is 43 degrees. Over here, I know this is a kite because my consecutive sides are congruent right here and here. And so because of that, I know it's a kite. And so we can say that this angle here is 78 as well. These are right angles right here. So I can do 90 minus 78 to get that this angle here is 12. So X is 12. When I do this one over here, I know that to get this angle right here, I could do 90 minus 41. So this is 49, which makes this one 49 over here. So Y will be 49. Okay, over here, they told me OV, which is right here, is 19. They told me SU is 14. So, and we talked about how on a trapezoid, on a kite, the shorter diagonal is it gets bisected. And so if that whole length is 14, this will be 7 and this will be 7. And for some reason, it did not ask me the question actually got taken off here, but it's wanting to know what the length of VU is. So you could do 7 squared plus 9 squared, or 19 squared, equals C squared, just doing Pythagorean theorem. And you can do Pythagorean theorem because you know that those are right angles right there. And so that's 49. I think 19 is squared is 361, but I can't remember. So I'm going to multiply it out real quick. Sorry, y'all. Yeah, 361. So we get 410 equals C squared. So C will equal the square root of 410, which I don't think simplifies. And so that would be our answer for VU. On the next one, we have OW is 6, and we have OZ is 8. And honestly, I can do, it's asking me for WZ. You just can't see that. I can do this without Pythagorean theorem because it's technically a 3, 4, 5 triangle that's been doubled because we have 6, 8, and that makes my third side 10. So this would be 10, but you can also do Pythagorean theorem. If you do 6 squared plus 8 squared equals c squared, you get 36 plus 64 equals c squared. So that's 100. And c will equal 10 when you take the square root of both sides. All right. Hopefully that makes sense. And if you have any questions, just let me know. Thanks.